I decided to start working on this vise project again. And I was looking at making this part here, this guy here. So I 3D printed it so I could actually get the size of it in my brain and how I'm going to do these radiuses. It's supposed to come out of a 1/2 inch rod. It's a little guy. Hello everybody, this is Chuck, and thank you for stopping by the channel. As I always mention, I appreciate your time. So we're over here at the Industro Lite Mill. You've seen videos on this where I purchased it and then rebuilt the head with the help of Dean from the Air Cave shop. Of course, he did it, I watched. But I haven't used the mill much since we did that. And here's a quick video of me working with the mill the other day. We're back from that, and if you really looked at the end mill, you'll see that there is some runout on the end mill. My good friend Tom Lipton on Instagram called it the Wiggler mill. What we're trying to do is produce these little guys right here, which is on this sheet here. I went back on the mill project, the mill vise, and I think you can see I've got the rotary table set up in here. I made a fixture using a three-jaw chuck, not a three-jaw chuck, but a drill chuck to hold this small part. And I did my first one out of brass. I was having problems, did one out of aluminum. But let's go back to the wiggler. That's the issue in this video. And I'm looking for suggestions, comments, what you guys would do. The outside of the spindle and the inside of the spindle are running at a total of 1 thou. So 1/2 thou, 1 thou TIR, 1/2 thou each side. That's acceptable. I'll take that. When I put an end mill in it, as you saw in the wiggler video in the beginning there, it's running at about 8 thou. And been trying to figure out what the problem, why am I having this problem? So when I purchased the unit, it came with some 3C collets. Figured that's what it is. It's got the drawbar for 3C collets, and I doubt that you can see it, but when you put a 3C collet in, it's only biting on a very small portion of it. This taper in here is not correct. So I've gone around and round and round about it, trying to figure out what's going on here. And interesting enough, of course, I got the book out that I have on the unit, and it says that this is supposed to be a Morse taper 3. The drive for the head is a Morse taper 3, and this is supposed to be a Morse taper 3. So, like the game show says, hey, call a friend. I know a fella, I forget where he's located, but he does have the same unit. And I called him and I started talking to him, and I says, well, what do you have here for the drive? And he says, it's a Morse taper 3. And he goes, if you use a Morse taper 3 with an ER32, of course you lose some headroom, but it's a quick fix, you know. Well, this won't take a Morse taper 3. I've fooled around here. I did a little putty insertion there to see, kind of get an idea of the taper. And if I go with a gauge pin in the unit, I get to the very back of the taper, so I know what that is. And using a caliper, I basically end up with dimensions here that I've got 730 in the back, I got 928 in the front, and I got about 400 thousandths of depth. So how do I repair this? Right now the 3C collets, and let me back up here for a second. The collets that came with the unit are 3C. I went to a little machine shop and bought the full set of collets, and they're doing the same thing. It's not working. I've tried everything so far. So, how do I fix this? I'm looking to the YouTube crew out there. You guys always got great comments, great knowledge, great ideas. And we'll see what comments you say. Here's what I'm thinking of doing. My first thought was, hey, turn the head parallel to the table, pick up the taper, and cut a 3C taper in it using a pencil grinder and grind it. Well, the collet actually goes very far back into the head. So I don't think. Come on, you're not going to find the key for me just while we're on the. There it is. It goes way back in there. So I don't think that's a viable solution now. What's the next solution that I'm going to try? Well, I'm first going to make. I know I'm pretty confident that the back of it is 730 thousandths on this taper. The front, when I use a Mitutoyo caliper, I'm not the best at that. I got a reading of 928. Yeah, I'm probably pretty close. So my first step that I'm planning on doing, unless somebody out there is smarter than me, and there's a lot of people smarter than me, my first thought is to, one, machine a plug and confirm what the dimension of this outside of this unit is right here, the outside of the spindle. Is it 928, 930, 935? What is it? Get me a nice tight pin. Unfortunately, I don't have a gauge pin that fits that. Once I have that, then I'm going to basically take and create a template of what the taper should be, and I'll go ahead and machine a plug to fit that taper and fit it and make sure that it's perfect. Well, what am I going to do with that, huh, Charlie? Yeah. So my thought is, and it's pretty crazy, but I think it'll work, and somebody out there can maybe help me, is if I can cut to match the taper here, and then cut on the inside, I'm basically going to cut a fill piece to put in there that meets the taper of the spindle as it is, and on the interior meets the 3C collet. So that when I put this in, I'll have that piece, it'll take up the slack, and I'll have the shim, let's call it a shim in there, to get everything on center. And check it from there. So that's where I'm at right now. I was working on this little part, and I can actually do it here. I can finish it. Knowing that the end mill is running out, I can go ahead and let the end mill run out. I'll have to retram the head now. I could finish here since the rotary table's all set up and machine it. My other option is go ahead and pull the rotary table, put it on my main mill, or just move everything to the main mill. I got to decide on what I want to do on that. So that's a lot of yakety yak here. A lot of smart people out there. I'm looking for some feedback, comments. Help me out here. I appreciate it. That's it for this video. I appreciate your time, as I always said, and thank you very much.